Okay, this video goes with the gas law review worksheet. I'm going to do problems 1, 3, and 5 and show you how this works. Okay, so the first thing is I read the problem, and as I read it, I'm looking for anything about moles or grams. Because the thing is, on this worksheet, you're either going to be using this formula, PV equals nRT, or you're going to be using P1, the combined gas law, P1 V1 over T1 equals P2 V2 over T2. And so if you read this whole worksheet here, or this whole problem, number one, you see there's nothing about moles or grams. And so we're not going to use PV equals nRT because N has to do with moles. So we're not going to use that one. We're going to use this P1 V1 over T1. So what I do is I just make a list of the given. P1, P2, V1, V2, T1, T2. If a container of gas starts out at a pressure of 12 atmospheres, so I'm going to put that there, and a volume of 23 liters, and a temperature of 200 Kelvin, and the pressure is raised to 14 atmospheres, and the temperature is raised to 300 kelvins, what is the new volume? So we're looking for V2. So we have the equation, P1 V1 over T1 equals P2 V2 over T2. Now I just plug in the numbers. P1, 12 atmospheres. V1, 23 liters. Okay, T1, 200 Kelvin. Remember, in gas laws, the temperatures always have to be in kelvins. P2, 14 atmospheres. V2, that's what we don't know. So we'll just write V2. T2, 300 Kelvin. Now, one thing to double check is that your pressure units have to be the same on each side of the equation. Atmospheres, atmospheres. You can't have one like millimeters of mercury in 1 atmosphere. So they have to be the same. Same thing with the temperatures. You always have to work in kelvins. Okay, so then you cross multiply. The 300 goes up here, and the 14 atmosphere goes down there. And then you solve for V2, and you should end up getting on your calculator that V2 equals 29.5 liters. If you wanted to round it to 2 significant digits, then it would be about 30 liters. All right, let's try another type of problem. Okay, this one says, what temperature will 4 moles of gas? Okay, right away, I see temperature 4 moles, so that lets me know that I'm going to be using PV equals nRT. And it says what temperature, and so I'm just going to solve right away for what T is with the variables. So I'm going to divide both sides by N capital R, and so I get that temperature is equal to PV over NR. Then I'm just going to plug in the numbers. Okay, so T equals pressure 5.6 atmospheres. Okay, times volume 12 liters divided by the number of moles, which is 4 moles. So sometimes instead of giving you the moles, they give you the grams, and then you got to change to moles. Okay, and then the R. Okay, with R there are two values. There's one that has the atmospheres in it, and there's one that has millimeters of mercury. So the atmosphere is just like 0.08206, something like that. I hope I remembered it right. And then the units are atmospheres times liters divided by moles Kelvin. Now the thing is about the R value, it tells you what units your pressure has to be in. See, those have to match. The volume, what that has to be in. The moles have to be in moles, and then the temperature, of course, that you're solving for is going to be in kelvins. So then you just solve this problem by taking 5.6 times 12 divided by 4 divided by this 0.08206. The temperature that I get is 205 kelvins. All right, let's do one more problem. Okay, so this one, a gas has a temperature of 14 and a volume of 4.5. If the temperature is raised to 29 and the pressure is not changed, what is the new volume? Well, there's nothing about moles in this problem. So right away, I'm just going to make this list, P1, P2, V1, V2, T1, T2. Okay, a gas at the temperature of 14, so I'm going to write, oops, that's not there, temperature goes 14 degrees Celsius, and a volume of 4.5 liters, so there, 4.5 liters. If the temperature is raised to 29, so the temperature is going up to 29 degrees Celsius, and the pressure is not changed, well, if the pressure is not changed, then we just don't need to worry about it. And so what's the new volume? So what we have is we have this equation, P1 V1 over T1 equals P2 V2 over T2. Since the pressure is the same, you can just omit it and just go V1 over T1 equals V2 over T2. And then you can plug in the numbers, except there's one catch. Temperatures always have to be in kelvins, and it makes a difference. So you gotta put them in kelvins. Okay, so this one will be 287 Kelvin, and this one 29, and this will be 302 Kelvin. Then you just plug the numbers in. V1, 4.5 liters, over T1, 287 Kelvin. That's equal to V2, that's what we're looking for, and T2 is 302 Kelvin. Okay, so then you cross multiply and divide, and you get V2 equals 4.7 liters. All right, so that's the basic types of problems that are on this worksheet. You can go ahead and see if you can do the rest of it. Remember, if it's asking for moles or grams or anything to do with moles or grams, use PV equals nRT. If it doesn't measure or doesn't mention anything about that, use this combined gas law. Okay, that's it.